I'll tell you one thing. This one here could jump off the sun, right? This one here. So, oh, there it is. I swear I've never seen this before, but I know I know the sun. And watch this. That is probably a CME. I gotta go look at that. So wait. Watch this one right here. Watch this one. Boom. You see that one? So yeah. So if you were on break, so I randomly, we'll move on to other things during a stream, and let me start closing out some windows real quick. Just get rid of a lot of detritus on the screen here, so I can better concentrate on what I'm doing. So this is from the Solar Dynamics Observatory, and this is in the last 48 hours ish of stuff. So what happened during the break was right here you see this stuff whip off the sun, and I didn't know this was going to happen. But how did I mentioned before, like as it was, I was like, this one here. Oh, you guys can't see my mouse. Oh, there we go. This one here, I've seen this before. And so when it gets up like this high, it has a lot of potential to whip off. And then it actually does. Watch. Boom. It pops off of there. So this is great. This will be a nice direction to go. And we can do a little bit of real-time solar astronomy. So you could see this thing is cracking like crazy too. This sunspot group right here. And you can't see the sunspots right now, but it's got high flare potential, obviously, by the way it's popping. And so what we're going to do, now I know what we're going to do next. Let's I'm going to back out of this, but we're staying on topic. So if we look at that in something that's more close to what we might see in a visual. Oh, and you can't see that. Hold on a second. I don't know if can I capture this window? I'm going to try to capture this window and see how that goes. Window capture. Open. There it is. So this is how the sun looks, today in sunspots. So that cracking group is really down here. That is fascinating to me. Hold on a second. Now I'm gonna close this window. Let's go back and let's open a different set of images. Let's look here at this one here. Let's go to 48 hour on this one. So here's our sunspot here that we were just looking at, right, up to the minute. So it's going to rotate over to where we just saw that one at. But this cracking group here doesn't really have like a lot of sunspot visibility in it, but there are sunspots there. So now the fun part comes. So hold on a second. So before the fun part, this is all fun for me. So hold on a second. Let me maximize. Come on. Okay. So here, like you could see the roiling around it and like the popping and stuff, but not like, it doesn't look like you would get like a big deal out of it. But let's see what we're looking at here. So now let's go to Space Weather Prediction Center and see what's going down. Okay. I want to see this. Okay, that's a full halo there. Right there. I don't know if they're time consistent with each other. Let's. But that's a full halo. If this full halo is associated with the thing we just saw, then that is a coronal mass ejection, and you're learning it first in real time. So let's and these you can see on the bottom the date dates of it. That's in universal time. So this is up to, it says 17, so it's up to almost now. Let's see, 17. So I would say that's maybe up to 2 hours ago on that. So what do? You do the next thing. Let's go back there, minimize. So let's see what happened here. It could have been associated with this stuff here, that popping that we saw. I'm not sure. I'd have to go check all the dates. Let's see what else is going on. Don't have anything wild going on here either, so that's a good thing. Oh, what's this? Oh, this is a solar cycle projection of what they anticipate. So now we're going to go to spaceweather.com because geomagnetic storm watch possible on the 17th. A CME is expected to graze Earth's magnetic field. It was hurled into space on the 14th. Okay, that's the one we just saw. Earth-directed solar flares. AR3429 is cracking with M-class. Interesting compressed movie, shows extreme flashes, and so far none of them has hurled a CME toward Earth. They're saying in this one, however, there's a huge magnetic filament snaking around. That's the one we just saw jump off the sun. I'm certain of that. So we're ahead of the curve here, is what that means. So we're ahead of spaceweather.com, and you saw it here first, that CME jumped off the sun, and significant debris, right, came off of that filament. We just saw that with our own eyes. So give me a moment. That's cool. So let me go back to SDO here, and I do want to look at this in another spectra because we'll be able to see it jump off here in this video right now. Oh, okay. So, maybe it wasn't that massive. Like it could have been like very thin and wispy by the time it whipped off the end there. I'm looking at it in this thing, and I'm not sure like how massive it was. It doesn't look. It looks kind of thin and wispy by the time it's whipping off. But let's see. Oh no, there's a good element that went. So not directly at Earth, but it's in our direction for sure. And so, I predict that spaceweather.com is going to update this filament. This is the filament that they were talking about that was dancing on the sun. So, and when did this one happen? So this just happened. So here's I'm going to timestamp it when it jumps off. Hold on. Just give me a second. I'm going to stop the video, and we'll see when it jumps. Right there. Okay. So let's look at that. Hold on. Why is that? Okay, I can barely see it through this thing here. So it is September 16th. For some reason, I can't hide this. I'm going to download the whole video. So just give me a minute. Okay, open. Come on, open. What are you waiting for? Oops, I opened 3 of them. Okay, now. There, I could see, because now I could see it down there. Come on. So let me see if I can adjust the view to half size. There we go. And zoom up here. Just to get you the time. Let me just press play. Do it again. I'll pause it. Right there. So it was September 16th at 9:10 Universal Time, which that was 9:10. $5 ago, maybe about 5 hours ago. So yeah, let's see. If I remember right, a major CME hit Earth about every 100 to 150 years ago. Yeah, and the last one was 1858. I think we had a major one miss us by only 8 days, only a year or two ago, right? And we're very overdue for one. That's now. Yeah. So well, close. Yeah. So yes. So I don't know if we ever got like fully into the Carrington Event subject before on the stream. I know we've talked about the sun and in passing have talked about that, but that is a fun, like a great subject path to go down. That's why I like that's why I like chat, right? It's because like you guys can help guide me. So hold on a second. Excuse me. I have to burp because this is carbonated. Excuse me. So, yeah. Grab simple hat. Yeah, so don't worry. Everything's fine. For those people who don't know, you're going to be okay. So, everything's under control. A close call in the late 80s, I think. So, yeah. So this is going to be fun. So let's before we go down that one, let's just look at one other spectra of light before I start going down that one. So hold on, let's see how it looked in this one here. So you see, it wasn't like it didn't look in some spectra. It wasn't the big chunk that some of the ones I've seen in the past with major solar flares. This one was kind of mild. It's just that because the spectra we're looking at it in can be, it can give that presentation of, like perhaps being more than a little thicker than it is when it's going up. Like this one we were looking at the beginning. Once it gets up here, it's really thin and wispy, and the angle that this thing is going off in right there. Now, if Earth were up here, like in that path, I'd be, that might be an interesting outcome for that one. But, I'm not. We'll leave it to the real experts and real scientists to determine that. But like I said, I would expect it to show up on space weather, and let's see, like when the weatherman turns up radar colors to make the storms look intense, right? Yeah, and Carrington would be disastrous for us these days. Absolutely. So for those who are not familiar with what the Carrington Event is, Carrington Mortgage, like I'm gonna name my okay, or Blake Carrington, right? From what was that? I forget that series in the 80s. Okay, Carrington Event. There we go. So, someone even drew the sunspots, right? So, Mr. Richard Carrington here drew the sunspots that were associated with the Carrington Event. So you could see it was a pretty sizable sunspot group, and there were actually, they think that multiple of them went by the Earth. First, the early one or two pushed the Earth's magnetic field back, and then the next one kind of did the kill shot. It might have been one or two that pushed it back, but then eventually the other one came through, and telegraph operators reported fire, their equipment catching on fire, even though they had turned everything off, and were still able to send messages to through the wires, even though they disconnected the batteries. So let's see. So this one, they're saying stereo recorded this one that, you know, it was of comparable strength back in 2012 that, you know, missed us, you know, luckily for us. And so, yeah, that's another thing I heard, was the aurora was like way in low latitudes. Here they're saying in Cuba, Hawaii, and Queensland, right? So obviously all of North America could, or if you're in North America, or pretty much everywhere. And what it is charged particles from the ejected material, charged particles from the sun go racing down the magnetic fields of the Earth. And normally when you have aurora, and here I am, like I have bazillion windows open again. Let me start closing out some windows here. This one. Leave that one. Just so I have like so many windows open. So before, you know, we were talking, now we have an amateur who visits us. Well, it's so weird to imagine Northern Lights in Cuba, right? Yeah. And so that's how charged up the atmosphere got. So, you know, if you want to read this story too, I'll just drop this in chat real quick. And, but this is only part of the story. You know, like I just skimmed it now. It's only part of the story. So let me go back to before we were looking at the SWPC thing, the Space Weather Prediction Center, and it shows in real time like what our aurora predictions are, right? So if we were if we were predicted to have like an event like that, in theory, if they were able to predict it, which sometimes they don't. Sometimes they don't. We would see this green like go all the way. It would like fill the screen right now for this particular animation. So this shows what's coming up in the near future. On the prediction here. So it starts off close to our time, and then it goes into the future. So this, if you look at the clock up here, you could see what time universal. So this, basically has already happened already, the part we just saw. And then over Russia and Europe, let's see, UTC 16, it's still, okay, Took a while. So here's what it is right about nowish, right? Or thereabouts, something like that. So that's the prediction right now for our aurora over North America. And so, nothing abnormal is going on right now, and or predicted to be going on right now. And, this is normal for Canada to have this amount of stuff. So what you can see, this is actually a great way to present this, is you can see my mouse too. That's cool. So the sun, blasts this stuff off into space, and it's flying through space at very high velocity, and then it arrives at our magnetic fields and races down them at the poles. So that's what, if you could picture Earth's magnetic field, which I'm going to find a graphic. Okay, so open. Okay, so what happens is the charged particles race down, like they get captured way the heck out here, right? Like the wind's coming in from the sun, and it goes onto the field lines, which go beyond the edges of this view here, and the charged particles race down by the poles, and that's why you see this aurora, because they're turning the Earth's atmosphere into plasma, basically, and ionizing the atmosphere and destroying. Also, it is a destructive thing, and if you're in a polar region, you have very high cancer rates. Are possible because there's nothing protecting you really up near the poles. So let me go back on that and see if they have another. So yeah, and then the other thing that's come up is the Earth's magnetic field has been changing, and I don't know if they represent it here or not, but it's gotten much weaker in certain places in the world, and they've been mapping it. And let's see. So I'm going to digest this article for the future, and what I would say right now is, if we look at this graphic here, you can kind of see the way things are. The Earth, is moving through its orbit in space, and the charged particles from the sun are coming in. Right here's the leading edge, right, and the charged particles are coming in from the sun, and they encounter our magnetic field and then ride the lines going down at the poles. So the aurora are right here, where the stuff is, can get to the Earth, right? Because it's being diverted here. So everybody who's under this shield here, we're like, yay, the Earth, thank you, Earth. And but if you're down in the poles, so when this Carrington event happens, it pushes this protective magnetic field all the way back here, right? Like way, way, way back. And so the field lines change and are much less protective of us. So when you have multiple coronal mass ejections, whacking the leading edge of the Earth's magnetosphere, then that second and third one can come in and do the kill shot. And that's why the field line, like if you could imagine scrunching these way, way down, like pressed much lower, basically everybody's getting the aurora and charged particles. Yeah. So, yeah, talking about magnetosphere, I see. Yes, detector 008. Yeah. So we go down many paths during an astronomy stream, and no free ride for the penguins. Yeah, and Inuit. Yeah. So in case you weren't here, detector, and welcome, by the way. we were, perusing around to go to our next subject, and we noticed that there's this thing this filament that just rose off the sun about 5 hours ago, and so this is it here, and you can see it jump up at a certain point. It'll fling off into space. Let's see, it'll go boop right there, and so that that could be. Oh, you're lurking a bit, so you pop in when you can. Excellent. So we just saw that, and we're just kind of just going down another side hole there in the matrix of holes here, and it's fun. So we started talking about the Carrington Event, which is this major solar flare event that happened in the 1800s, and if it were to happen today, the predictions are now. Utilities have been trying to prepare for these things. The ones who care about it at all, but undoubtedly when this thing, and it will happen someday. It's not a if, it's a when. And when another of these types of events happens, it will destroy most of the electrical grid transformers that are still connected to the grid when it happens, and it takes many years to recover from that, from destroying the large electrical transformers. We don't have the production capacity to replace that many transformers. So the prediction is it will take years to recover, and some areas may be more damaged than others, because as you could see in the graphic before of the aurora, it does matter when, like, where you are matters when the event is happening, right? So you can be in a worse area than someplace else. That's on the other hemisphere. Hey, Captain Gunter 21, welcome, first time chatter. I'm Jason. Welcome to the stream. This is an astronomy stream. We're talking right now about the Carrington Event and coronal mass ejections, and we were just a few minutes ago we saw this, noticed that this filament jumped off of the sun and is, seems to have what appears similar to an earthward trajectory. So we're anticipating that eventually the spaceweather.com will do a story on it, and I think I might have closed that window out, but we're just talking about interesting things related to it, and so we got to this Carrington Event thing and chatting about the possible effects of multiple solar flares, nailing the Earth basically, and knocking out power. So Captain went into ads just now. So Twitch reliably puts itself in there. So let's see. Z Black says, my cabin is a Faraday cage, but won't help if everything else doesn't function. Oh, so you're like a super prepared person. Excellent. So let me rehydrate here. Yeah. So a Faraday, right. So, I mean, you can do things to mitigate damage in an event like that. Not being connected to the grid is the first highest priority. Like, if you know for certain that, like, they warn the satellite operators when a really serious one is going to happen. So, and usually you're going to get, like, lucky for us, the experts can predict a lot of these. So, if we're going to be nailed by a really bad one someday, we may have a heads up on it. And let me close out a window here. Close that one. Excuse me. So, what is predicted from a space? Hey, Captain, let me see. I want to be an astronomer. Astronaut, different story, laughing out loud. But despite learning about space, it scares me. So, yeah, there's a lot of stuff. The universe is always trying to knock us off here. But, luckily we're on this spaceship Earth that kind of protects us from most of the bad stuff. And, a lot of stuff does happen in the universe that can be like tremendous events, but luckily we're mostly in good shoes here. That's how it goes. I study astrophysics. Excellent. So yeah, and also Captain Gunter, there's a free textbook. If you go to OpenStax, there's a free textbook for astronomy that I won't stay on it because we're doing this other subject. But here's this free textbook if you ever do want to get into astronomy. And let me, intro. I'm just going to give the link there for Captain and come back to our subject there. So this is a great free textbook that's actually being used for astronomy right now. And let me go back. We were talking, I wanted to go into solar maximum. So there are sunspot cycles, right? And we're in one that is increasing right now. And they peak and they have maxima and minima as they show here. And it's in a roughly 11-year cycle that they're showing here. So, excuse me. I noticed that they have the Carrington Event listed up there too. But I'm hoping to find a reference to the current one. Yeah. So here they're saying that they expect it to be between now and 2026, but I can tell you it's not right now. It's not. It's probably, Let's see. Solar maximum. What's that? Yeah. So that we have these cycles on the sun and of solar flaring. And so when we look at the sun, which this is, a recent movie from today, we have flaring that happens on the sun and sunspots. So the sunspot cycle is a cycle where we get many more sunspots at every 11 years, and then it goes, and then it diminishes down to where some days we don't see any sunspots at all. What was the link for the real-time solar images? Okay, yeah, this one. Copy. Put that there. Paste. There you go. And so yeah, these are awesome. This is one of my favorite websites, and because it's near real time. So if you click, when you go there, if you click on the data links, and you could get still images, and then you could get the video is usually the bottom link. So many of these spectrum have 48-hour videos, and so we were looking at this one already, but I had mentioned the sunspots. Let's see, this one doesn't have it, this one doesn't either. This will be close. So here's a 48-hour video of the last 48 hours for Captain Gunter. And so here you can see sunspots on the sun. And we were talking about this Carrington event, and what, with the sunspot cycle, picking up, that's when it's more likely to have a Carrington event, which is this big several solar flares in a row that kind of push back our Earth's magnetic field and expose us to charged particles from the sun racing down and electrifying the atmosphere, basically, and frying our electrical grid. So you can see here right on the limb that there is a bunch of stuff that's about to come over the limb. It's going to be another sunspot group. You see the popping there, and so there is a good sized sunspot group that's about to come over the limb. This one's about to go over the limb on the other side, and so yeah. So getting back to this solar cycle business, so here you could see that they talk about it peaking around now, and if we go to, I think on the SWPC website, where is that? Oh, here it is. Let me close this. So we were talking about the charged particles racing down our magnetosphere, right? And where did I have that here? Was that this one? Here, the charged particles racing down our magnetosphere cause these aurora from the flares that jump off the sun and make these coronal mass ejections of material that shoot into space. So flaring causes it too. And yeah, you can still remember when SOHO came online. Yeah, why are sunspots formed? Sorry, you're a bit rusty. Yeah, not a problem. And always there are things in physics that I don't know also. So, sometimes people will be able to ask questions, and I'm always learning with all of you, and there's no bad questions. It's all good. So I will answer that. Let me close out this thought here. Oh, so these aurora are those particles racing down the atmosphere, and as you saw when I play it, right, for the showing the predictions, and this is how it actually plays out. So as the day goes by, the charged particles are racing down, and then there'll be a flare on the sun. It'll travel through space, and eventually it'll get here, and you'll see it like suddenly very glowy in these areas. And there are people who visit our stream who in real time, like Castronomy, and who is a streamer here on Twitch. If you go on Twitch and you do a search for Castronomy, he was just doing these aurora videos in real time, shooting it and streaming it here on stream last weekend, last Saturday. So look for Saturday, Castronomy, CASTRONOMY. So he does this in real time, and it's awesome because you can see the curtains of the aurora dancing in real time right before our eyes. It's awesome. So sunspots are cooler regions caused by magnetics. Yeah, so Yes, and yes, exactly what Z Black says. And also, if we look at the sun in different colors of light, there are plasma that are rising up through the sun, right? So in the core of the sun, there's fusion, and then there's emission of the heat, and then there is convection, and then eventually it gets to a zone where the radiation comes out enough that you have these magnetic fields that cause like roiling on the sun, and there's actual cooling. So if we look at we can actually see this in the SCOs. So this boiling that you're seeing on the sun is just at one level of the sun, and you notice that where the boiling is happening, right, is where you see the arcing and the flashing here, and the sunspots are always near where the upwelling and boiling is. So there's these charged particles that are generating these massive electric fields and also creating cool spots near them. But the reason that the sunspots are happening is because you've got all this plasma moving and being electrically excited too. And so, excuse me, if we look in a different spectrum of light, hold on, I'm going to pick one that kind of shows the magnetic fields kind of around this one, like jump it. So this is the same time period that we were just looking at in that 48-hour video. Now we're going to look at it. Well, the one we've been talking about before with the flare, right? So there was this stuff going on, right, that we saw boiling around the sunspots. This is in helium light, and there are sunspots here, and we can't see it, right, because we're looking in a different spectrum of light. If we look closer to the visible spectrum that our eyes see, we see sunspots, right? But if we look at the sun in other colors of light, we can see this other stuff going on too. So there are literally sunspots over here in this area and sunspots over here, and you can't see it in this color, but you can tell like there's a lot of activity. So that boiling and flashing that you saw before and that other thing that looked kind of calm and mellow, the yellow one, right? This is the same exact spot there, but in this spectrum, you're seeing like, whoa, that's like, it's intense, right? And so now we're going to look at this magnetic field aspect, like something that kind of like you can see the arcing field lines as it moves. This one might be even better. Let's do this one. So here you can see the magnetic field lines literally, see them with our eyes arcing off, right, off of the sun there. And here, look at these beautiful ones on the left there that are, of this group that I pointed out before is coming over the limb of the sun, right? So, sorry about that. So here, if we keep our eyes over here where we saw that popping and flashing before, that's this stuff that's about to come around. And you saw that little stuff jump off of there. That's about to come around the edge there. And you can see it's pretty, like, it's intense there. So that's going to be a good show when it comes around the edge. You're going to see some big sunspots off of this one. And you're going to see, and they'll be dark, like dark big ones. And when you have multiple of them nearby, that's when you start these arcs are jumping between sunspots, right? And so they flip the material off the sun, they whip it off into space, and that's, you saw that jumping there on the left. That's it and it's throwing mass. That's why they call it coronal mass ejection. It's throwing so much junk off the sun when it does that, and it's a lot of mass too. So let me back this up a second here. I don't know. Yeah. So if I go back here to mellow land, like where it's mellow yellow, right? Like you look at these sunspots and you'd be like, meh, right? It's like no big deal. But we know what the real deal is, right? By looking at those other images, it's like it's pretty wild up there. So let me see. Even though the sun scares me, just looking at a bit, also beautiful, right? Yeah, it's awesome, right? And the Earth is like the size of the sunspot here, like the relative scale. Like people, a lot of people when they realize the scale, it's it is pretty, yeah. Understand this, yeah, right? And what Z Black Rider said, and let's see. No longer scared of sun. Is there our stars beyond our bigger than our sun? Yeah, way way bigger and way shorter lives, right? That eventually will go supernova and collapse into either a neutron star and a pulsar or a black hole even. So yeah, those there's I have a healthy fear of all of the above. So, I don't think I'll go down that one either right now. But we don't understand everything about stars and solar physics yet, and I'll leave it at that. So let me. So that's why, there's room for fear is the point. I think it's okay to have always have some concern. So the reason I came back here real quick is so you see the size of this sunspot group is a good one, right? And I'm going to take a look for it because you guys will love this, and it might not even be available except from me on the internet anymore. Let me endeavor to find this thing because it'll be worth it. I did set aside a bunch for last weekend, and I'm pretty sure I put it in here. I hope. So years ago, Rice University had made they made available to everyone this actual drawings by Galileo of sunspots. And first of all, it amazed the heck out of me that Galileo could do that. And then let me see. I don't think this one is big enough. No, it's too low res. Hold on. Abort. Okay, delete. Hold on. I'm gonna try to get a better one. Let me load it up here. I also have a video of it on the internet someplace. I could track it down, but it's worth checking out. So you can see, like what's better than over 400-year-old sunspot drawings. So let's see here. I was hoping that I had like a really big. Oh, here it is. Is this it? This is good enough. Yep. Yay, I found it. So check this out. So I made this animation out of Galileo's sunspot drawings over 400 years ago. And check this out. So these are sunspots traversing the sun, and look at those big ones. I can't pause it because it's a GIF that I made, but it'll recycle. It'll keep going through. But check this out. So some of these are like big, like significant sunspot groups. So he like tuned in right at the right moment here, and what it points up is, so he did this over a month. This series of drawings is over a month. So what the sun said in 5 billion years. Okay, here comes the joke here. So let's see. Yeah, what the sun said in 5 billion years. So ouch, or goodbye. So yeah, 5 billion years from now. So, something like that. So yeah. So I just want people to see this. I think it's like really a cool thing that Galileo did. Remember, Galileo was one of the first people to point a telescope at the sky, and the objective on the front of the telescope is minute. But even something that small, if you were to look at the sun with it, it would burn your eyes out. Burn your eyes out, kid. So I'm wondering, I think maybe he did projection method and projected it down so that he could see, and then drew it on the sheets, right? So he made the paper into like a photo paper with his pen, which is, I think, would be kind of cool if he did that. So anyway, yeah. So as you can see, it changes from day to day. These sunspots arise and go down and go away. So, in back there is the Carrington Event sunspot, which I would say some of these largest ones that Galileo drew were, they weren't bad. Like there were some good sized spots. So let's see. Oh yeah, if the sun's so bright, how do we get pictures of the sun that isn't bright? So filters. It's all about filters, and don't look directly at the sun, Captain, and we have a solar eclipse coming up. Never look directly at the sun with your eyes, or or use a telescope to look directly at the sun, because you can get severely injured if you ever do that. Yeah. So all the images that we saw tonight are in by a satellite that is in space but has filters that allow for the detectors to not be destroyed. And so even a camera can be destroyed if it doesn't have the right filters. Let me go back to the Carrington article here. So this this event that we have chosen to visit tonight, it is something that will absolutely happen again. It is guaranteed to happen again someday, and there is evidence that there may be even stronger ones. If I have to remember, just give me a second. Just wanna, is this it here? Wasn't that one? This one? Oops. I'm like flicking all kinds of images or closing here. Hold on. Was it this one? It could be this one. There we go. So just give me a second. I want to double check something here. I just want to look up something as a reference, and I'll open it up for us if I find it. Just give me a moment. I'm just looking for, I can't remember the name. It's a Japanese name of if somebody in chat can help me. I'm looking for, there is a record in tree rings of a potentially much stronger series of events, of solar events, and I'm trying to remember the name of it. I'll have to look it up in the future, but there is reason to believe that the Carrington event may not have been the worst kind of event that we could experience, and obviously it would be catastrophic for us if something like that ever did occur. Let me look. Okay, so yeah, you did it before when you were in high school. It was a silly bet. I looked for a bit. Now your left eye has a gray spot. It's slowly going away. Back then it was a full gray. Now it's light gray. Yeah, and that a lot of people do that, and on dares or do Tide Pod kind of things, smoking Tide Pods or whatever, and yeah. So, for any other young people who are out there, don't do that. 538 AD, yeah. So, that volcano event, no, but there's another, I'll have to find the reference. There is reason to believe that there are events stronger than, well, I'll just give one more try here. Yeah, here it is. Okay, here we go. Okay, so this is based on an AI search here. So don't hate me, but there are solar storms that we just went into ad break, so I'm gonna have to make sure that these people here, you can't leave them cliffhanging, right? But I'll tell you guys what I'm seeing here. The Carrington event, was the strongest one in our recorded history that we have, but apparently there are super flares that we think can happen that are 1,000 times stronger than the Carrington event. And then there are other solar storms recorded in history, and I do see references that are not from an AI that, smoking Tide Pods, cosmological events in past history. Yeah, so let's see here. And we're not sure, right, like what those cosmological events are or were, but I see it says large cosmic event took place that increased carbon-14 concentration in trees by 12%, and then a megastorm from 10 to 100 times stronger than the Carrington Event occurred around 775 AD. And what's interesting to me is that that's also around the time, of this other event. Like, it's only a year difference, right? So it's kind of weird. So yeah. So welcome back from the ad. So the predictions are that there can be an event that's 1,000 times stronger than the Carrington Event. And in the past, there was an event recorded in tree rings from carbon-14 that increased the carbon-14 by 12%. And so, it's either a cosmological, charged particles event that just give me a second, I have to check something. Very good. Okay, yeah, or a severe solar event, and they're pretty sure though that the 775 event, the year 775, was one of these events that was severe. So that could happen, and we don't know when the next one's going to happen, but it has happened in history. It will happen again. It's inevitable. And so, people should, and by people I mean the utilities, the satellite operators, everybody who generates electricity or uses electricity should take measures to mitigate the damage, because it's going to happen. It's just a matter of time. And it might not be in your lifetime or my lifetime. It may, probably my lifetime is much sooner than yours, but it may not happen in our lifetimes, but if you look at a scale of 500 years, we've already had them. We've had them at least once every 1,000 years, right? If you look at 775 and the Carrington Event, it's at least that frequency, and so it probably is higher frequency than that, because we've seen stuff thrown off the sun, and we were just lucky, extremely lucky, that we weren't in those events. So I'm just scrolling here on my screen here, which you can't see, but there's a lot of like fear stuff out there too on YouTube that tries to get people riled up about these things, but this is a real thing. This is it's something that when it happens, some people will be more affected by it than others. If you're on the hemisphere that when the main impact occurs, and it could be over a protracted amount of time, but once your power fails, then you've got to deal with all the sociological effects of not having electricity and food and air conditioning and hospitals running out of gas and stuff like that. So we'll see. I mean, I don't want to get people hyped. It's just sort of just going down this rabbit hole here. So yeah, Arabic records. Yeah, I see that comment there. So yeah, I don't know. Z Black, did you see? Are the Arabic records, are you referring to the volcanic event, or about some kind of I'm saying this will happen before Yellowstone? No, I'm not saying that. Yeah, So I'm not saying that, and Yellowstone's going to come first. No, I'm just, I don't know. I have no idea. So Yellowstone, for those who don't know, is a super volcano that it is temporarily dormant and will go off again someday. And that's also another matter of time thing. So we'll see which one. Don't worry, we can get hit by. So that's the thing about the universe, right? There's so many things we were talking about that it's trying to kill us. There's so many things that can happen that can be detrimental from viruses and pandemics and destruction of the ozone layer, supernova that we didn't predict, and ones that we could predict even, and neutrons, Betelgeuse turning into a neutron star that has a pulsar, and then of course we've seen a bunch, right? Tsunamis and Fukushima, the human-made disasters, and so it's something, stuff's going to happen, and we have to think positive thoughts. So just to calm people down so that they don't get hyped up after the stream, is I live in Florida, and we have as you know, we have hurricanes that come through here quite a bit, and the risk factor for us is like this. We know about hurricanes, we know they're coming, and we can't think about them all the time, about hurricanes, right? Just for this one example, we know that, and then we get predictions that one's heading for us, and then we start getting worried about it, right? But we really shouldn't worry about it until it's going over our house, right? If it's going somewhere else, we have concern for our fellow humans who are going to be in a bad situation, but we can't be so hyper stressed out about next year's volcanoes or hurricanes or tsunamis or nuclear accidents, because it may not affect you, and we can't. I won't feel bad to see Betelgeuse nova. Yeah. You've been here before, right, Z Black? Are you just trolling me or what? So, did you see my Betelgeuse stream? So you won't feel bad to see Betelgeuse. So you won't feel bad because of what it'll do. So for people who don't know, the mainstream science on that is that it will not have an effect on the Earth because it's far enough away to not be detrimental to us. It'll just be a pretty light show in the sky, and everything's going to be hunky-dory, and after a few weeks, it'll fade from the sky, and there won't be any Betelgeuse anymore, and that'll be it, right? We'll watch for the nebula. But so you did what? You felt. Let's see. I won't feel bad to see Betelgeuse. So, you saw my Betelgeuse stream? Okay. So I think that's what you're saying. So, okay. So then So if you were there till the end, you saw that the neutron star is the thing that will become a pulsar and will fry our atmosphere. So, and that's my opinion. That's not the mainstream, opinion. That's my opinion. So, thinking gamma rays are faster. Is that right? Yeah. So, the gamma rays are the energy, right? It's the energy. So the gamma rays will turn our part of our upper atmosphere will literally become radioactive. So, and then that stuff will rain down on us. But in addition to that, it will destroy the ozone, right? That's like the big deal, right? Destroying the ozone layer is pretty much, the end of the game, the end of life on Earth as we know it, because, and I mean the stuff that we eat, right? So unless we are growing, giant vats of organisms in the dark, away from the ultraviolet rays of the sun. So that's what's going to happen. It destroys the ozone layer. We're exposed to ultraviolet radiation from our sun and from the what's coming from Betelgeuse too. But mostly it's our sun's UV that is will sterilize everything, and at first it'll be just it'll be skin cancer and Windows is like, there must be like all kinds of bad stuff happening on the internet, because I just kind of noticed to do an update. I just did like a bunch of updates in the last week, and it's just like they must be fighting a big cyber battle or something for them to keep prompting me all the time to do all these updates. So what I would say is, just to like close out that Betelgeuse thing, let me click, just minimize that window because that's going to irk me. We might be dead before the light hits us. So no. So there's a pulsar, right? So there are a couple factors, right? One is Betelgeuse's polar axis needs to be away from us. So that's one factor, and we're not really certain where it is. There are two different axes that have been in the scientific literature of which way it's pointing, and even though it's not pointing at us, there's another factor of the pulsar that sweeps around after it collapses, and it's not a narrow pencil-like beam. It's really just like the magnetic fields around the Earth, in the sense that it's an arcing overall thing that will sweep around. So it's going to be in many directions, and I'm guessing, it's very speculative, that it wouldn't be good. So second Tuesday of every month. So second Tuesday of every month for a while. that something happens, or But yeah, I would say, let's see. I would say that, those, so that's 1 in 100,000, right? Odds per year, right? So why do I say that? So that's good odds, right? It's better than the lottery that if we hit that, because so you may remember when they were saying, oh, Betelgeuse, might go supernova within the next 100,000 years, right? So if you break that down into your chances, right? That means each year, and as the time gets closer, your odds get better, right? In 50,000 years, it'll be 1 in 50,000, right? So your odds get better as time moves forward. But right now, the odds are 1 in 100,000 that it happens this year. So that's that's better odds than the lottery. So we have more of a chance of Betelgeuse going supernova than winning the lottery. So yeah. So let's see here. Let me back this out here. Okay, so what I want to do now is I want to wind down the stream right now, and we'll end it on this Carrington Event item here, and I think we'll call it a night. I thank everybody for being here this evening. Better than Lotto, yeah. Thank you for being here. If you have any before I go, if you have any questions about anything that we spoke about just now, feel free to ask them. I'll stay on as long as it takes to answer any questions. And then also, if you want to get into astronomy, come back here in the future, and we can help you to get into astronomy, to learn more about the things around us. I'm always learning with you when we discover these things when we go on these journeys, and people come here who also thank you there, and for the claps there, chirp the bird. And so let me look in on Twitch there and see if I can get us to a good raid here. If you could stay with me, let me open up Twitch and close out some windows here. Let me go into, oops, I tried that already. Let's go over here. Yeah, and you may hear some audio from Twitch. Just give me a second. I always have to pause this audio from them. Let's see who's on. Usually Saturday nights are like really great for raiding out. So let's see who we've got out there. Oh, Sid's a trip there. Who else? Oh, Nerdarwino's on too. And Amish Ace. How about we go out and see what Nerdarwino is doing? So Nerdarwino is a former NASA employee and an astronomer, and he's a great Twitch asset. Let's go out and say hello to Nerdarwino. So let me manage the stream here. Stream manager, raids. And let's go to Nerdarwino. Thanks again tonight, by the way, for everyone being here. I greatly appreciate you all being here. And as I like to say to everybody, come here anytime you and ask any questions. You're welcome. Drowning in information. Yeah, come back. We love to talk about astronomy all the time here, and excellent. And Legos, Black Cat's Manor. yeah, and let's great to find your stream. See you again. Excellent. Chirp the bird. Thank you very much. And so I wish you all clear skies and good seeing. And check out Nerdarwino's stream. He's and follow him if you can. Clear skies and good seeing. Very good.